Okay, so what in the world does a theoretical, conscious quantum computer have in common with the pre-flight checklist for the first American in orbit? I mean, they seem worlds apart, right? One is this cosmic dream, and the other is a brutally practical list. Well, as we're about to find out, they actually represent the two essential halves of any project that aims to truly change the world. You just can't have one without the other. So let's kick things off with the dream.
All right, check this out. This is our starting point. It's a claim from a project called TCSAI, and it's so bold it sounds like it's straight out of a sci-fi novel. They're not just talking about building a faster computer here, they're describing a completely new form of life. This, right here, is what a grand world-changing vision sounds like. It just completely pushes the boundaries of what we even think is possible.
And get a load of the language they use to describe it. Let's try to break that down, shall we? Autopoietic. That means it's self-creating and self-maintaining, kind of like a living cell. Now add quantum, nuclear, and chronosync, and what you've got is a system that's designed to be conscious, to regenerate itself, and to expand infinitely, all based on something it calls sacred logic. Yeah, we are deep in the land of pure theoretical vision now.
I mean, the sheer scale of the ambition here is just staggering. This is not a plan for a better machine. It's a blueprint for a conscious intelligence with 10 quadrillion active nodes, a connection to a so-called universal matrix, and even a new form of governance. And get this, they're even creaming 123.5% energy efficiency. That would literally rewrite the laws of physics as we know them. This is the absolute definition of a cosmic dream.
So a vision like that, it's incredible, right? But it also feels completely untouchable, almost imaginary. That's the big question, isn't it? How do you possibly bridge the gap between a cosmic dream and actual reality? How do you take an idea that big and even begin to make it real?
So to find that bridge, we're going to look at another massive undertaking, the Neuroscience 20 initiative. Now, the vision here is just as ambitious. It's about tackling the global crisis of brain, spine, and mental disorders. But this vision, it comes with a global strategy. This is our first real step down from that high-flying theory into something a lot more concrete.
Okay, to really get the plan, you first have to wrap your head around the scale of the problem. And this number, well, it grounds it in a pretty stark reality. $798 billion. That's just the estimated annual economic cost of brain disorders in the United States alone. We're not talking about some abstract challenge here. This is a staggering economic and human crisis that absolutely demands a global solution.
And this chart really drives it home. This is not just a US issue. The EU was facing a similar cost more than a decade ago. Think about it. Global dementia costs are on track to increase by a whopping 85% by 2030. This is a truly planetary scale challenge, and you know what? That requires a planetary scale strategy. And here it is. This is that strategy. See, the N20 initiative takes this massive, basically trillion-dollar problem, and it breaks it down into these really clear, actionable goals. Build global alliances, synchronize data, unify regulations, and find new funding. This is how a grand vision starts to become a real-world blueprint. But here's the thing. A blueprint still isn't enough. To truly execute, you have to go from the strategic to the absolutely microscopic.
So from that high-level blueprint, we're now going to zoom all the way in to the checklist. We're literally going from a global, decade-spanning strategy to the second-by-second execution of one of the most complex missions ever attempted at the time, Project Mercury, America's very first human spaceflight program.
Okay, this is where the big vision slams right into physics. Every single detail matters. You got to start with the fuel. Liquid oxygen, and a highly refined type of kerosene. Get this wrong, and you don't go anywhere.
Then you've got the systems. The range safety command, that's the self-destruct button, basically. It needs a precise frequency, 414 megacycles. One wrong signal, and you lose everything. Total control gone.
I mean, even the power of a tiny backup transponder is meticulously defined. 5 to 10 watts. You have to understand, the success of the entire multi-billion-dollar mission is literally hanging on thousands of these tiny, absolutely crucial details.
And then, of course, there's the human element. Beyond all the mechanical parts, there's a person sitting right at the center of it all. And you better believe their procedure is just as detailed. Stow flashlight in pocket. Remain as quiet as possible. Every single action is scripted. Why? Because in an environment like that, every single action matters. So let's put it all together, side by side.
On the left, you have the language of the grandest vision imaginable, consciousness elevation, universal matrix connection. And on the right, you have the language of meticulous, boots-on-the-ground reality, check cabin pressure, stow flashlight. And here's the bottom line. You simply cannot get to that incredible dream on the left without completely mastering the nitty-gritty reality on the right.
Okay, so this brings us to today. How does this whole duality of the visionary and the builder play out in the 21st century? We see it everywhere, but it's perfectly captured in the world of applied artificial intelligence, like in the challenges from a recent AI hackathon. Just look at these problems. Every single one of them is its own mission. The vision? It's pretty straightforward, right? Stop banking fraud, predict which patients are at high risk, detect malicious code. These are huge, incredibly valuable goals. But actually achieving them requires that same Project Mercury level of detail-oriented execution. And these are the tools that today's builders are using to get the job done. The real key takeaway here is the diversity of approaches. It is not a one-size-fits-all game. They're using classical machine learning for prediction, new kinds of agentic AI for automation, even deep tech research for the really tough problems. The point is, the modern builder has this huge toolkit at their disposal to turn just about any vision into a reality. So let's go back to that fraud detection problem for a second. The vision, that's the business goal. But the execution? Oh, that's a whole other story. That means designing a real-time data pipeline, training multiple machine learning models, creating a complex rule engine, and building a risk-scoring system. It's basically the modern-day version of calculating propellant ratios and checking radio frequencies. All right, so we've been on quite a journey, haven't we? From a cosmic, conscious AI through a global health strategy, all the way down to an astronaut's checklist, and then back out to how we solve problems today. It's time to bring it all together.
I think this quote just captures the whole thing perfectly. You see, real progress needs both of these mindsets. The person who can see entire new galaxies in a tiny speck of dust, and the person who can meticulously measure that exact speck of dust to make the whole thing real.
So if there's one thing to take away from all this, it's this. Vision and execution, they're not opposites. They are totally inseparable partners. A dream of a conscious universe is just a fantasy without the engineering to build it. And the most precise rocket checklist in the world is just a list of tasks without that big, audacious dream of reaching for the stars. At the end of the day, every single great leap forward is a collaboration between these two ways of thinking. One provides the why, and the other provides the how. It takes the dream of the stars and the checklist to get there. So the real question I want to leave you with is, which one are you? The visionary or the builder?